Hi, this is Ms. Fitzmaurice, and this is an explanation of Practice Quiz 1 for regular physics in the fall of 2014. So, for each of these questions, we basically have to worry about what kind of graph we have, and then we have to think about this chart, XVA, which will tell us whether we can read it off the graph, find the slope, or find the area. Okay, in our first question, it says the accompanying graph describes the motion of a toy car across the floor for 10 seconds. What is the acceleration of the toy car at t equals 4 seconds? Okay, so looking at this graph, we have a velocity time graph, okay, and we want acceleration. So if we have velocity and we want acceleration, we need to find the slope. Okay, it wants the slope at 4 seconds. I'm going to take any 2 points along the line right here. Okay, so I've selected these 2 points. My rise right here is 1. My run is also 1. So my justification, I'm going to write A equals slope equals 1 meters per second, that's my rise, over 1 second, 1 meters per second squared, and that is option C. In my second problem, it says, for which time interval did the marble have a negative velocity? Okay, so again, we look at what kind of graph we have. It's a position time graph. To find velocity from position graph, we have to look at the slope. So if we want to know about negative velocities, we look to see where this graph has a negative slope. And it has a negative slope in these 2 places, and those 2 places are 4.8 to 6.2 seconds and 6.9 to 10 seconds. Okay, so my justification is going to be negative slope equals negative velocity. So these justifications don't have to be really long, but they have to explain the way you're finding your answer. Okay, so number 3, it says the motion of a circus clown on a unicycle moving in a straight line is shown in the graph below. Okay, it asks, after 12 seconds, how far is the clown from her original starting point? Okay, what we have to do, because we have a velocity graph and we want how far, we're looking for position, so we have to find the area. I'm going to break this into some triangles and some rectangles in order to calculate the area. Okay, remember that the area for a triangle is equal to 1/2 base times height. The area for a rectangle is base times height. Okay, so I'm going to go ahead and do that for each one of these squares, and when I do that, I should end up with 24 meters. Okay, my justification is, so from velocity to change in position, find area. Okay, and I'm just going to put answer as D. In number 4, it says, between what times did the object have a non-zero acceleration? Okay, I have a distance graph. I know that for position time or distance time graphs, acceleration is equal to 0 when we have a line acceleration is not equal to 0 when curved. Okay, so I want to know, where is this graph curved? and it is curved from 5 to 8 seconds, so that is option D. Okay, in number 5, it says the position versus time graph for an object moving in a straight line is shown below. What is the instantaneous velocity at t equals 2 seconds? Okay, so it's an xt graph. We want velocity, so we have to find the slope. So my justification is find slope, and I want it at 2 seconds. I can use any 2 points on this line. Okay, my rise, okay, it's going down, is going to be -4. My run from 1 to 2 seconds is going to be 2 seconds. So I have -2 meters per second, which is answer A. Okay, number 6, it says which of the following would best represent acceleration versus time for a bouncing ball? Okay, if a ball is falling down, then we know our acceleration is negative, so I'm looking for either D or B because those have negative accelerations, but when it's coming up, it also has negative acceleration. So after bounce, our acceleration is also negative because even though it's coming upwards, it's slowing down. So there's only one graph which has acceleration before and after the bounce, and that is graph B. Number 7, it gives me this equation, F equals G capital M little m over r squared, and it wants me to solve for r. So I'm going to solve for r algebraically first. Okay, so I have F equals G m for r squared. I want to bring r up to the top, so I multiply both sides by r. And then I want to get rid of the f, so I divide both sides by f, and I end up with r squared equals G m over f. I take the square root of both sides to get rid of the squared, and I have r equals the square root of G m little m over f. Now I can plug in my numbers. Okay, so I plug in G is 3, capital M is 2, little m is 6, f is 10. I put that into my calculator and I get about 1.8. Okay, circle area formula. So this one is just asking us to algebraically solve for r and pi. Okay, so first of all, to solve for r, first we have to divide both sides by pi. We have r squared equals a divided by pi. To get rid of the squared, we take a square root, and we have r equals the square root of a divided by pi. Okay, to solve for pi, all we have to do is get the r squared away by dividing both sides by r squared. So we end up with a divided by r squared equals pi. Finally, in number 9, it says the velocity versus time graph for the motion is shown in this diagram. The thick line represents velocity, and we want to know at what time is the car the greatest distance from where it started. Okay, so this car, first of all, we have a velocity time graph. We want to know about distance. Okay, so we have to find the area. Anywhere above the 0, we have a positive area. So this is all positive. Anywhere below the 0, it's negative, so we're going to have the greatest distance. So my justification is find area to get displacement at largest positive area. We are the furthest away. Okay, and we can see that that occurs. We're getting more, gaining more, gaining more, gaining more. We have the most, and then we have to start subtracting. So the largest positive area is at 5 seconds, and that's answer B. Finally, in number 10, it says, consider the motion of an object given by the position versus time graph shown. Where is the speed the greatest? Okay, so we have a position versus time graph, and speed is kind of like velocity, and we want to know where it's the biggest. So we're looking for the biggest slope. Okay, and it looks like it's steepest right here. You might be saying, wait a second, that's negative. How could it be the biggest? The thing is that speed is always the absolute value of velocity, so it's steepest right here where the slope is steepest, even though it's negative, and that is time equals 4. So I'm going to justify this, it's answer C, by saying to get speed, look at steepness of slope for position time, or xt graph. I hope this video was helpful. If you have any more questions, please don't hesitate to email me. Good luck on tomorrow's quiz.